You must have seen many triangles in your life. Are they all of the same shape? Think for a while. Absolutely right. Triangles differ depending on the sides and the angles. When we talk about the classification of triangles based on angles, then we compare the angles of the triangle with the right angle. If all the angles of the triangle are smaller than the right angle, then we call it as an acute angle triangle. And if any one of the angles of the triangle is greater than the right angle, then we call it as an obtuse angle triangle. But if any one angle of the triangle is a right angle, then such a triangle is called a right angle triangle. As you can see, some triangles are shown here. Pause the video and find out which triangle is a right angle triangle. As you can see, the triangles shown in figures 2, 3, 5 and 8 have one angle as a right angle. So, this is a right angle triangle. Consider figures 1, 4, 6 and 7. None of the angles here is a right angle. Therefore, we cannot call them a right angle triangle. Children, in a right angle triangle, sides are given special names. In a right angle triangle, the side opposite the right angle is called the hypotenuse. In a right angle triangle, hypotenuse is the longest side. The sides that are smaller in measure than the hypotenuse are called the legs of the right angle triangle. Pythagoras, a great mathematician and a famous philosopher of the 6th century, discovered an important property related to the hypotenuse and the remaining sides of the right angle triangle known as the Pythagoras property. Let's understand this property. Here is a right angle triangle ABC with the measure of the hypotenuse AC as 5 cm and among the remaining sides AB measures 3 cm and BC measures 4 cm. Here, the measure of one of the sides of the right triangle is 3 cm. Let's draw a square with this measurement. As you can see, here we have drawn a square with side 3 cm. We will place this square along the 3 cm side of the triangle in this way. Similarly, we will draw another square with side 4 cm and place it along the 4 cm side of the triangle. And we will draw a square with side 5 cm and place it along the 5 cm side of the triangle. Can you tell me what will be the area of each of these squares? Think for a while. Let me tell you. Area of a square is equal to side multiplied by side, which we represent as side square. Note that whenever you see 2 written above any number a, we call it the square of the number a. This means that the number a is being multiplied by itself twice. That is, the area of a square with side 3 cm can be written as AB multiplied by AB is equal to AB square, which will be 3 cm square, that is 3 multiplied by 3 cm square, that is 9 cm square. Along with this, note that a square with area 9 cm square has a total of 9 squares with side 1 cm in it. Generally, how many squares of side 1 cm can be drawn in a figure is known as the area of that figure. Now, let's find out the area of a square of side 4 cm. Here also, we can say that the area of a square of side 4 cm is BC square is equal to 4 cm square is equal to 16 cm square. Similarly, the area of a square of side 5 cm is equal to AC square is equal to 5 cm square is equal to 25 cm square. Here comes an interesting point. Guess what this is? Think for a while. Correct. Here we see that 9 cm square plus 16 centimeters square is equal to 25 centimeters square. Or, in terms of square of sides, we can write it as AB square plus BC square is equal to AC square. This is an interesting relationship between the hypotenuse and the remaining sides of a triangle. In other words, we can say that in a right triangle, the square of the hypotenuse is equal to the sum of the squares of the remaining sides. We know this by the name of Pythagoras property. This property has many uses, such as if the two sides of a right-angled triangle are known and we have to find the third side, or to prove that a given triangle is a right-angled triangle. Note that the Pythagoras property can be used only for right-angled triangles, but this property cannot be used if the triangle is not a right-angled triangle. Today we have learned right-angled triangle and the Pythagoras property. In the next video, we will see some examples related to these. Rahul travels 15 steps east from his position and travels a distance of 8 steps towards north. If the distance of all the steps are equal and one unit is equal to 1 step, then find out how many steps he is away from his initial position. You must be knowing that we represent the directions this way. On this basis, let us draw a figure for the given situation. Rahul travels a distance of 15 steps from his position towards east. We will show this by drawing a line segment towards the east direction, whose length will be 15 steps. Let's name this line segment AB. It is also known from the question that Rahul travels a distance of 8 steps towards north from the point B. Tell me, how can we depict this? Think for a while. Absolutely right. Since the north and the east sides form a right angle, we will draw a line segment forming a right angle with the line segment AB from the point B, whose length will be 8 steps. We will name this line segment BC. We have to find the distance between A and C, which we show by the line segment AC. As you can see, a right-angled triangle has been formed here, in which the side AC is the hypotenuse and the sides AB and BC are the legs of this triangle. In triangle ABC, we know the measurement of two sides. Therefore, by using the Pythagoras property, we will find the measurement of the third side, that is the hypotenuse AC. Here, AC is the hypotenuse and AB and BC are the remaining sides of the right triangle. According to the Pythagoras property, in a right triangle, the square of the hypotenuse is equal to the sum of the square of the remaining sides. That is, AC square is equal to AB square plus BC square is equal to 15 square plus 8 square. We get 15 square is equal to 15 multiplied by 15 is equal to 225. Similarly, we get A square is equal to 8 multiplied by 8 is equal to 64. Since 225 plus 64 is equal to 289, hence the hypotenuse AC square is equal to 289. To find the measure of AC, we need to find the number whose square is 289, that is, multiplying the number by itself gives 289. We see that 10 square is equal to 10 multiplied by 10 is equal to 100. Similarly, 20 square is equal to 20 multiplied by 20 is equal to 400. Since 289 is between 100 and 400, so the number whose square is 289 will definitely be between 10 and 20. Similarly, we get 15 square is equal to 15 multiplied by 15 is equal to 225, which is closer to 289. While doing this, we find that 17 square is equal to 17 multiplied by 17 is equal to 289. That is, AC square is equal to 17 square. This way, we can say that the measure of the hypotenuse AC is 17 steps. From this, we come to know that Rahul is 17 steps away from his initial position. Example 2. Dinesh has to draw a right-angled triangle. Can you tell which of the following measurements he should take so that he is able to draw a right-angled triangle? We are given 3 measurements in each statement. Find how many of these statements can create a right-angled triangle. If created, what will be the measurement of the hypotenuse? Think for a while. Let me tell you, in a right-angled triangle, the measure of the hypotenuse is greater than the remaining 2 sides. With this understanding, we can find the measure of the hypotenuse. In the first statement, we see that 9 cm is greater in measure than the remaining sides. So it can be the measure of the hypotenuse. According to the Pythagoras property, in a right-angled triangle, the square of the hypotenuse is equal to sum of the squares of the remaining sides. We will use this property to determine whether or not a right-angled triangle can be formed by the measurements given in the first statement. Here, the square of the hypotenuse is equal to 9 cm square is equal to 9 multiplied by 9 cm square is equal to 81 cm square. And the sum of the squares of the sides is equal to 6 cm squares plus 8 cm square is equal to 36 cm square plus 64 cm square is equal to 100 cm square. Here, since the square of the hypotenuse is not equal to the sum of the squares of the remaining sides, a right-angled triangle cannot be formed by the measures 6 cm, 8 cm and 9 cm. Coming to the second statement, we see that the largest value here is 13 cm. So it can possibly be the measure of the hypotenuse. Here, the square of the hypotenuse is equal to 13 cm square is equal to 13 multiplied by 13 cm square is equal to 169 cm square. And the sum of the squares of the remaining sides is equal to 12 cm square plus 5 cm square is equal to 144 cm square plus 25 cm square is equal to 169 cm square. Here, since the square of the hypotenuse is equal to sum of the squares of the remaining sides, 13 cm, 12 cm and 5 cm can form a right-angled triangle. Similarly, check yourself as to whether a right-angled triangle can be formed by the measurements given in the third statement. Today we saw examples related to right-angled triangles and Pythagoras property. In the next video, and the Pythagoras property. Misconception 1. Can you use the Pythagoras property to find the measurement of the side AB in the following triangle? Some children ignore the fact that the Pythagoras property can be used only for right-angled triangles. But this property cannot be used if the triangle is not a right-angled triangle. They think that here, one side is greater than the remaining 2 sides, or sometimes it is not given in the question. But just by guessing, they consider that the triangle is a right-angled triangle. They think that Pythagoras property can be used in both these situations. But to this misconception, they give the answer as option 1, which is an incorrect answer. We know that the sum of the 3 interior angles of a triangle is 180 degree. That is, angle A plus angle B plus angle C is equal to 180 degree. Angle C is equal to 180 degree minus angle A plus angle B. In triangle ABC, angle A is equal to 70 degree and angle B is equal to 25 degree. Here, the sum of both the angles angle A and angle B is 70 degree plus 25 degree is equal to 95 degree. Therefore, the measurement of the third angle is 180 degree minus 95 degree is equal to 85 degree. Since none of the angles here is a right angle, the triangle shown here is not a right angle triangle. Since this is not a right angle triangle, we cannot use the Pythagoras property. Here the correct answer is option 2. Find the measure of the hypotenuse xz in the following example. Some children simplify it using the Pythagoras property. Xz square is equal to xy square plus yz square. Since xy is equal to 6 cm and yz is equal to 8 cm, therefore xz square is equal to 6 square plus 8 square is equal to 36 plus 64 is equal to 100. After getting this sum, they forget to find the value of xz from xz square. They assume the value of xz to be 100 cm. With this understanding, they give the answer as option 2, which is an incorrect answer. Note that 100 is the value of xz square. To find the value of xz, we need to find a number whose square is 100. Since 10 square is equal to 10 multiplied by 10 is equal to 100, so we can say that xz square is equal to 10 square. Hence, xz is equal to 10. As a result, the correct answer to the given question is option 1. Misconception 3. In the right-angled triangle, triangle ABC, AC is the hypotenuse and AB and BC are the sides. Find which of the following statements is true for triangle ABC. Statement 1. AC square is equal to AB square plus BC square. Statement 2. BC square is equal to AB square plus AC square. Statement 3. AB square is equal to AC square plus BC square. Children do not understand the Pythagoras property properly. They think that in a right-angled triangle, the sum of the squares of any two sides is equal to the square of the third side. With this understanding, Statement 1, Statement 2 and Statement 3 appear to be correct to them. So, they give the answer as option 1, but this is an incorrect understanding. The correct understanding is that the sum of squares of any two sides in a right-angled triangle is not equal to the square of the third side, but only the sum of squares of the sides smaller than the hypotenuse is equal to the square of the hypotenuse. Therefore, the correct answer here is option 2. Today in this video, we saw few misconceptions related to right-angled triangle and the Pythagoras property.